What do you mean by total internal reflection? I'll explain you with the help of this diagram. I'll explain you with the help of this diagram. See, in this case, let us consider that you have a object, and your object is at denser medium. Focus on my word. I will strike a light from denser medium. Okay. Now, first you will perform this thing. First, what you will do? First, you will strike your light here. If you strike your light here, it will go out. As a refraction, it will go out. As a reflection, some part of the light will bounce back. Then what I will do, then I will just change the angle. If I just change the angle like this will follow the angle of reflection. And this, as we are moving from denser to rarer, so DRA, it will move away from normal. It will move away from normal. Again, then if I again increase the angle, what will happen? This will strike here. As angle of incident is big, angle of refraction will be big, and as it is moving from denser to rarer, what we will use the concept of DRA. That means from denser medium it will move away. Okay, see, if you check, as you are increasing the angle of incident, this lights are getting bent. So there will be a time, there will be an angle when this entire ray will be bended on the surface, water surface. See, there will be an angle at which our ray will be absorbed, or it will fall on the water. That angle is known as critical angle. What it is known as? Yes, it is known as critical angle. If I again increase, if I again increase this, then entire ray will get reflected. There will be no refraction. Initially, what happened? Initially, when you strike from here, when you strike the light from here, it bounce back. Then if you change the angle, it will again it will follow DRA, again DRA. Then what will happen? It will be completely absorbed. After that, there will be nothing to move out. Everything will be reflected. So after see, this angle is known as critical angle. After critical angle, the rays will get totally reflected back, and that phenomena is known as total internal reflection. Okay, for total internal reflection, you will have to remember one thing. You will have to remember that it should move from denser to rarer. Second thing, your incident angle should be greater than critical angle. What is critical angle? The critical angle is the angle at which the refracted ray would be 90° from the normal. Okay, it will be 90° from the normal. So what will be the definition for total internal reflection? Now let us see. The light transitioning from optically denser medium to rarer medium at interface undergoes partial reflection back into the same medium and partial refraction into the second medium reflection. Then behavior during refraction. A ray of light entering from denser medium to rarer medium exemplified by ray deviate away from the normal, as I've explained in the diagram. Okay, if you increase the angle of incident, angle of refraction will also increase. Then after that, there will be a time when when angle of refraction will be 90 degree, and after that there will be no angle of reflection. Why? Because the entire light will come bounce back into the same medium, and that phenomena is known as angle of, and that phenomena is known as total internal reflection. Okay, then let's see the demonstration one by one. Optical phenomena can be effectively demonstrated using a laser torch or pointer, which is easily accessible. For example, a glass beaker with clear water is utilized, stirred with soap or induced slight turbidity. Partial reflection and diffraction. Directing the laser beam from below the beaker, striking the upper water surface, demonstrate partial reflection and partial refraction. What about total internal reflection? By adjusting the laser beam to strike the water surface obliquely, one can find an angle where refraction is entirely absent. The beam undergoes total internal reflection, returning to the water. Pouring the water into long test tube and shining the laser from top replicates total internal reflection, simulating the behavior in optical fiber. Keep a safety precaution that avoid direct eye exposure to the laser beam and to refrain from pointing it at anyone's face during the experiment. It have a very large high intensity. It can damage the pupils. So just have a safety precaution when you are performing anything with the laser light or the optics. Okay, then what are the applications of total internal refraction? First, mirage. You know what is the meaning of mirage? Usually in the desert area during the summer, when there is no water in the desert, but still we can be able to see the water. Yes, so that is known as mirage. Why you can see the water? Because of this total internal reflection. Okay, so see, on summer days, the air near the ground heat up more than air at higher altitude. The refractive index of air is directly related to its density. Since hotter air is less dense, it has smaller reflective index than cooler air. When the air is relatively still, the optical density increase with height. Consequently, with the light from the tall object like tree transverses through the air, its path bend away from the normal due to the decreasing refractive index towards the ground. If the angle of incidence for air near the ground surpasses the critical angle, the total internal reflection occurs. As a result, to an observer and distance at a distance, the light seems to be originating from below the ground, creating the illusion of reflection. Similar to the pool of water near the tall object, this optical illusion is known as mirage, and it is very particular common in hot desert environment. Okay, then second application of total internal reflection. See, in the case of diamond are renowned for stunning brilliance, primarily attributed to the total internal reflection of light within them. The critical angle at the diamond air interface is minimal, approximately 24.4 degree, increasing the likelihood of total internal reflection once light penetrates the diamond. However, naturally occurring diamond often lack the expected brilliance. It is the expertise of diamond cutter that enhances a diamond sparkle. Through the precise cutting, the diamond can undergo multiple total internal reflections, contributing to its exceptional brilliance. Okay, then we have for prism. Prism designed to bend light by 90° or by 180°. Such a prism are also known as an invert image without changing their size. Then we have optical fiber. We all know about the optical fiber. Okay. In modern times, the optical fiber are widely employed for transmission of audio and video signal over extended distances. These optical fiber leverage the total internal reflection phenomena. They are manufactured using high quality composite glass or quartz fiber, each composed of a core and cladding. The core material has a higher refractive index than the cladding. Signal transmission in optical fiber. Optical fibers are extensively utilized for transmitting audio and video signal over long distances. Total internal reflection is the key phenomena employed in optical fiber. Then we have fiber structure. How fiber are made? Optical fiber are made from high quality composite glass or quartz fiber, each comprising a core and cladding. When the light in the form of signal is directed at one end of the fiber, at an appropriate angle, it undergoes repeated total internal reflection along the fiber's length. The length eventually emerges at the other end of the fiber with no significant loss in intensity. Optical fiber are designed to enable light reflected at one inner surface to strike the opposite surface at an angle larger than critical angle. Even if the fiber is bent, light can still travel along its length. What are application of optical fiber? Optical fiber can work as it has the ability to transmit a light signal effectively. In nowadays, the Wi-Fi, even the television system, they all are using optical fiber for transmission of the signal. Because in that case, we don't have much scattering of the light, because the light waves, the light rays are bouncing back in the same medium. We have the diverse application like bundles of optical fiber have various uses such as transmitting and receiving electrical signals. Medical appliances. Optical fiber are used as light pipe in the medical context. The facilitating visual examination of internal organ like esophagus, stomach, and intestine. We need total internal reflection. For decorative lamp, we often use optical fiber, where fine plastic fiber creates fountain-like structure with light appearing as dots at the free end when the lamp is switched on. The main requirement in fabricating the optical fiber is minimal light absorption during long distance transmission. Materials such as quartz undergo purification and special preparation to achieve this, allowing over 95% of light transmission over 1 kilometer length of silica glass fiber. This is how you can find a mirage. An observer perceives a tree at its location when the air above ground maintains consistent temperature. Consistent temperature. at higher temperature. See, if layer of air in proximity to ground exhibit temperature variation with the hottest layer closer to the ground, the light emanating from distant tree might undergo total internal reflection. This can lead to an optical illusion for the observer, creating the false impression that the tree is situated near a body of water. Okay, this is the concept of mirage only. Let's see the next question. I'll give you 1 minute time for answering this question. Yes. The question is, in the context of optical fiber, which of the following characteristics is consequence of total internal reflection? In the context of optical fiber, which of the following characteristic is a consequence of total internal reflection? Constant signal propagation is the right answer.